Okay, so hello everybody. This has to be fast. This is Hybrid Buffer Pool Lightning Edition. I hope I can do it in 10 minutes. We'll see. We're going to talk about the good, the bad, and the ugly. And yes, a little bit about me. My name is Thomas Grohser. I'm with SQL Server for 27 years, and yeah, I'll like to push it to the limit. So having a feature like Hybrid Buffer Pool, I, of course, immediately had to test it. Moving on from that. So before we talk about Hybrid Buffer Pool, the hardest part of comparing things is it's not always a clear comparison between apples and oranges. I mean, it's hard enough to compare apples and oranges, but in the world of computer features, apples and oranges sometimes get mixed together, or one is disguised as the other. So when you compare features, it's not always easy. And Hybrid Buffer Pool drops right into that category. And then, of course, there's the problem that is called marketing that tries to disguise the actual things so they distract you. And yes, this guy looks like my demo slide. So, Hybrid Buffer Pool, how does it work? What Microsoft did is, with the development of NVMe drives that are really fast, with persistent memory, which is basically a memory chip that when you turn off your computer doesn't lose what's stored in it, while a regular memory chip, if the computer loses power, it is. So what you can do is your query processor, you have your normal buffer pool, you have a data file. Your data file, your buffer pool is in memory, your data file is on your SSD, and so on. And what you can now buy is one of these little pieces of memory that are persistent, and you can create another data file on that memory chip. Yeah? And that means the data is stored on that memory chip and nowhere else. Yeah? If now a select query comes along that needs data that is stored on that file that is in the persistent memory chip, instead of SQL Server going through the query process and the buffer pool requesting it from the data file, it serves it directly back from that memory chip. Yeah. So that is, of course, much faster than transferring it into memory and then returning it from the buffer pool. So that's the easy case. If it would be a regular page, it would have had to be pulled in and then returned. So that's the slower version. So buffer pool, Hybrid Buffer Pool, much faster there. So what happens on a write? On a write, Microsoft cannot just write and modify the page in the Hybrid Buffer Pool. In that case, they have to bring it into the regular buffer pool as with any other page, modify it, and then write it back to the Hybrid Buffer Pool. So Hybrid Buffer Pool, not good for data that constantly changes, because then the data will not be in the Hybrid Buffer Pool. Hybrid Buffer Pool, very good for lookup data. Yeah, your slowly changing dimensions in a data warehouse, a really good place. Constant loop joins into that can be very, very helpful. Yeah. So this is how it works. Requirements for the Hybrid Buffer Pool. You need to have a server with persistent memory. Persistent memory right now is expensive, but performance has its price. You need Windows Server 2019, doesn't work in anything earlier. You need SQL Server 2019, doesn't work in anything earlier. You need a volume on that PMEM formatted, so the PMEM must run in the mode in the where it provides the drives. It can run in a mode where it just plays memory, and that you cannot use. So when you have it in a mode, you format it. Windows NTFS just supports that. And the important thing is it has to be 2 megabyte cluster size. If you format it with the 64K or any other value, you can't use it. It has to be 2 megabytes because SQL Server wants to talk to it in 2 megabyte chunks. And the data file must be a multiple of 2 megabytes. So it works on a 2 megabyte file, 4 megabyte file, on a 50 gigabyte file if you have enough of P memory. It doesn't work on a 5 megabyte file. Yeah, so simple as that. You can create a new one, or you can move an existing file by literally copying it into that drive or moving it into that drive. So detach the database, move it there, reattach the database. TSQL commands for to do this in 2019 and up. Auto server configuration, memory optimized hybrid buffer pool on. Auto server configuration set memory optimized hybrid buffer pool off to turn it off again. Then it becomes a regular disk file on there, and you have to move it away. For each database, you have to set memory optimized on, and of course you can set it off. And you have in SUSE configurations how the hybrid buffer pool is configured for the server. And you have in SUSE database a new column which is called is memory optimized enabled to see if it's on or off. That's pretty much it. It's a very transparent feature. You will just see a difference in performance. So that's now the important question everybody wants to know. What's the speed? Sorry, we're going to need a little bit of algebra and calculus to get there. So what I've observed, and this is with the NVMEs I bought, this is with the memory chips I bought, this was on the main board on the computer I had. Yeah, so I cannot give a general performance thingy, yeah, but ballpark numbers was if something ran in memory at the time X, it took 4 times as long to run it in PMEM, and it took about 16 times as long to run it off an NVMe drive. Yeah, so that's roughly the numbers. So basically, memory 16 times faster than an NVMe drive. And here we're talking scanning data pages. We're not talking any other operation, file server, something like SQL Server, scanning data pages, no writing, just the reading part. And now what I tested, and because I knew it's going to be there, and this is where the apples and oranges comes in, it really depends on the size of the data you want to put in the hybrid buffer pool. Yeah, how helpful it is or not. Yeah, from just the raw speed, you think everything's going to be 4 times as fast. But the problem is, if your workload is smaller than you can have a buffer pool. Yeah? And remember that these persistent memory chips are sharing memory slots. So to get that, you have to reduce your buffer pool. So if your workload fits in the original buffer pool size, the first scan takes 16 times the time because it has to pull it from the NVMe drive, plus 1 time accessing it from memory. Every subsequent scan of the data takes just the memory time. Yeah. So the average becomes this little formula that I would normally spell out, but in the quick version, not. If you run calculus on it, it becomes X. So over time, the first 16 extras on the first time don't count. If you read the same lookup table a gazillion times, the initial loading it from drive doesn't matter. Yeah. So if everything fits in memory, you have still speed X. The loading from the disk doesn't matter. If it doesn't fit in memory, then you have the problem that you keep taking 16 times the original, just the memory time to run it, because you have to load it from disk over and over again. And again, NVMe drives are fast, but it's fast. So if it fits into the hybrid buffer pool, so it's smaller, then you have the 4x performance. So these 3, it's either X, 17x, or 4x. So base speed, if you fit it in memory, you will be the fastest things. So I made a diagram to make this clear. This is your normal memory that you have. To get persistent memory, you have to give up half of it, and then you can fill it up with 4 times as much persistent memory. And again, you can buy different chips. That's the maximum you can get. Yeah. So instead of like 1 terabyte of memory, you now have half a terabyte of memory, but you get 4 terabytes of extra memory, of persistent memory. So if your database is in this size range, basically would fit into memory or the data you want to have fast, yeah, then it's not a good idea to put it into PMEM because you will make it slower. If it fits in PMEM completely, but is bigger than it would fit in the original amount of memory, then it's a very good idea to put it in persistent memory. If it becomes any larger, you run out of persistent memory. There's not like add another one because you run out of memory slots. Then you can't use it again. And to make this very clear, that longest green stretch is exactly the size of the persistent memory. Yeah. So that little green range is where persistent memory makes total sense for reading data. If you write intents, it's just going to take away your buffer pool again, and most likely will not make it much better.